So part 3 of 2.5, 2.6. Now we're looking at example 5, and we're writing equations of tangent lines using the power rule. So again, make sure that you guys, when you guys reading the problem, make sure that you're looking for those keywords here. So here we're looking specifically for the equation of a tangent line, right? And tangent line is just that. It's just a straight line. So it's something, again, in the format of y equals mx plus b, right? But since now we're in calculus, we're going to be using the other one, right? We're using the point slope format, which in this case would be y minus y0 equals f prime times, actually this would be f of a times f prime of a times x minus a. All right, and then again here, so we have to find our f of a, our f prime of a, and what our negative a value is. And we already have two of those three, which would be here. This is our a comma f of a. All right, so we can start writing our equation. Y minus negative 1 equals, and then we have our prime, which is still the thing that we have to find, x minus 1. All right, so I just need to find the slope pretty much, and that's it. So I need to find f prime, and then we're going to do that. So this is going to be f prime of x. So this is pretty much, you bring it straight down. First derivative of x is just positive 1. And then you have a constant here, which is negative 2. So negative 2 times your n is positive 2. And that gives us x to the first power, right? So from there, we move forward, we're going to end up with f prime of x equals 1 minus 4x. All right, and then here there's a word of caution for you guys. It says a very common mistake is an example like 5, part A, is to think the slope of the specific tangent line is 1 minus 4x. So it's important that you find the specific slope, so that at the point 1 comma negative 1, in this case, they give it to you guys right there, f prime of 1 equals negative 3. So we have to substitute. We have to figure out what f prime of 1 is, which would be our f of a. In this case, 1 minus 4, like it says right there, times 1 gives us negative 3. And then here, we just simplify a little bit more. So we plug it in now where we had it, and that gives us y plus 1 equals negative 3x plus 3. And then if you want to leave it in the first format, that's perfectly fine. If you want to leave it in y equals mx plus b format, then you could always just rewrite it, y equals negative 3x plus 2. Here, pretty much, as long as you have those three elements, right, the f of a, the f prime of a, and the negative a inside your point slope form, then you should pretty much get a correct answer, all right? Okay, now looking at example B, we want to write the equation of the tangent line to the function at the given value of x. So again, here we have our y minus f of a equals, again, f prime of a, and then x minus a. And again, the things that I have, so I have f of x equals 2 times the square root, right? I'm looking for, again, the equation of the tangent line. And then I have x equals 1. So they're only giving me the a value here, right? So I need to find what's f of 1. I also need to find what's f prime of 1, right? So actually, yeah. So y minus f of 1, and then this is going to be x minus 1. So I still need to identify f of 1 and f prime of 1. So let's find f of 1 first. So 2 times the square root of 1, that gives us 2, right? So y minus 2. And then over here, we'll find the f prime of x. So 2 times the square root, so 2 times x to the 1/2, n is 2. I'm sorry, the constant is 2, and then times 1/2, which is n, and then n minus 1 is negative 1/2, right? 1/2 minus the 1 gives us negative 1/2. So again, here simplify, and then you just end up with 1 over the square root of x. And again, this is not the equation of the tangent line. This is the equation that gives me the slope at that specific moment, right? So now we can find f prime of 1 is going to be 1 over the square root of 1. So we just have positive 1 pretty much. So again, y minus 2 equals 1 times x minus 1. And again, you can stop right there. This could be your answer. You can always simplify, right? So you can have y equals distribute, and that's going to be x plus 1, your final equation 2. Now, it says finding location of horizontal tangent line. So this is a different story, right? So we're looking at so if we have a curve, right, we have certain values where the lines are horizontal right there. In a horizontal slope, right, if you guys remember from Algebra 1, what is the slope? Is pretty much just your zero slope, right? Your undefined slope is your vertical slope. So here what you want to do is we're looking to see, right, when does this happen, right? So the horizontal tangent line. So first we need to figure out at what points does the graph of y equal. So we need to figure out when is that equal to 0? When is y prime equal to 0? Okay, so that's pretty much the essential question here. If we want to find the horizontal tangent lines, when is y prime equal to 0? So in order for me to do that, I need to find y prime. So y prime is equal, again, applying the power rule. So n is 2, so 2 times x to the first power, and then 4 times x to the first would be just plus 4. All right. And then I'm looking to see when is this equal to 0, right? Because that's pretty much what I'm looking. So 2x plus 4 equals 0. Subtract 4 from both sides. You have 2x equals negative 4. Therefore, x equals, again, negative 2. So at x equals negative 2, all right, y prime equals 0. But now it says at what point? So make sure we're answering the question, right? At what point? So I still need to find, that means since I only found one value, that means there's only one value where this line has a slope of 0. I'm sorry, a tangent line with a slope of 0. So all I have to do is find y when x equals 2. So I plug it in. So that's going to give us negative 2 squared plus 4 times negative 2 minus 1. So that's 4 minus 8 minus 1. That gives us negative 5. So this graph has at x equals negative 2, y equals negative 5, a tangent slope of 0 or horizontal. So now looking at example 7, ensuring tangency to a given line. So given the function f of x equals x to the third power plus k times x, and the line y equals 6x minus 2, find the value of k so that the line is tangent to the function. So here we have a function, right? And then this is ensuring tangency to a given line, right? So in a way, these two functions have to be touching each other at one point only. And then we're asked to find that k value that makes that true, all right? So pretty much what I want you guys to imagine, I'm going to show you guys the graph. So we're looking for k value here. We have f of x, right? I already plotted it. And then we're going to move this around until we see pretty much, if you notice right there, it's seeking, right? So for sure, on the negative side, it's going to be somewhere on the positive side, maybe close to somewhere there, right? Maybe somewhere around right there. So maybe between, I would say 2 and 3, or 2 and 4, actually. So let's find that value using the calculus behind it, right? So again, if you haven't realized this, if this line has to be tangent to f of x, then that means that's our slope, right, at that point. So pretty much that's our f prime of a is equal to r to 6, all right? So in this case, since we already know that, and now we have f of x equals x to the third plus k of x. What we want to do is first find the prime. So f prime of x equals, using the power rule, that's 3x squared. And then the derivative of x is just 1, so this is just going to be plus k. And then we want to figure out when is that going to be equal to positive 6. So I'll set that equal to 6, right? 3x squared plus k. And then here we're going to get an equation with k equals something, which is what we want. So subtract 3x squared, and that gives us 6 minus 3x squared is equal to positive k. All right, now we're going to use this pretty much to figure out that value. Now, here, another thing that you guys do have to realize: if these two functions are touching each other at that same value, that means they have to be equal to each other. So I know x to the third, right? So x to the third plus kx equals 6x minus 2, all right? Because they're pretty much together at that value right there. And not knowing what k is, so I have x to the third plus, I have k, which is 6 minus 3x squared, and then times x equals 6x minus 2, right? So again, I can set these equal to each other because they have the same value at that point, right? They're only touching at that point. So they're going to have that point in common. And here again, you want to simplify because we want to try to solve for x. So that's going to give us positive 6x minus 3x to the third power equals 6x minus 2. I take it a step further here. So again, solving for x. Take away the 6x from both sides. That makes it a lot easier. That is going to give us x minus 3x squared, negative 2x to the third power equals negative 2. And then divide both sides by negative 2, and we have x cubed equals positive 1. So therefore, just x equals 1, right? If you take the cubic root, you still end up with positive 1. So here we know that at a, the a value is equal to 1, all right? Or in this case, now that we know that, we want to plug it in to figure out what k is, right? So this is going to be 6 minus 3 times 1 squared equals k. So that's just give us k equals positive 3. And now we know pretty much the function, right? So y, or f of x, equals x to the third plus 3x. And then you can confirm that again looking at the graph. If you guys set it at 3, right? Right there. So they have the point in common at 3. When k is, so the point in common is actually 1 comma 4, right? But k has to be equal to 3 for this to work, right? And we did find that over here, right? X equals 1. So x equals 1, and then the y value would be 4, pretty